Is factoring by grouping a possibility here? Feels like no matter what, you're going to get an x minus 1 here, not an x minus 1 there, right? So the answer is no, it's not. So you make your possible list. Plus or minus, the things you're going to synthetically divide by are factors to the last over factors to the first. What are the factors of the last number? 8. 1, 2, 4, and 8. Factors of the first, I threw you a bone and made it only 1. Yeah? Now when you go to see which of those is a solution, I could put in 1 and see if it works, or 2 and see if it works. And that's possible. We typically use synthetic division because it handles, or it does multiple cases quicker. When you use synthetic division, you put the coefficients along the top row, and then you say, I'm going to divide by, and in that box you divide by something. Say, I tried 1. Talk to me about the process of synthetic division. What's the first thing I do? Give me a roller. Bring down the 1. Give me something next I do. Multiply 1, that number down there times the divisor 1, and where do I record it? Second column. Then what do I do with those numbers? Add, and then do the whole process over. Oops, this is positive 1. Multiply, record it there, add. Multiply, record it there, add. Did I have success? What tells me if I had success or not? Remainder is 0. Where's the remainder? The last number. All right. Do you remember what that does tell you? Is this, other than no being a no, do you have any idea what that does tell you? This actually tells you a point in the graph. When x is 1, y is negative 6. Now, that's below the axis, right? What does a cube normally do at the positive side? Isn't it supposed to go up on the positive side? Yeah? Right now it's a negative 6, so it still has to cross through the axis here. I'm still expecting it to be 0 somewhere, so that tells me I should probably try something above 1, maybe 2. If I try 2, do I get success there? Yes, I do, okay? So, x equals 2 is success. Here's where I had some people falling into an error here. Oops, darn it. Okay, now there are two schools of thought here. People then say, all right, I found one. Now I'm going to go back and synthetically divide by something else. 3 or 4 or 8, or not 3, but 4 or 8, right? Yes or no? No, you will not do that because you will never find the other solutions that way. Never, right? So when I say here, you might not have been clear what I meant by this. Rewrite the polynomial. Take a pause here and say, right now that x cubed d blah 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 equation, I have decomposed it into x minus 2, which is what I was getting at when I said x minus the successful root times the depressed equation at the bottom. This here is the quotient. When I divided x minus 2 out, that's what's left. Now if I had x cubed and I divided out x, then what's the power of what's left? X squared. It's 1 less. That's why we call it the depressed equation. It's decreased in power by 1. Now you might say, I still don't understand why I can't synthetically divide. Well, here's why. How can I solve this equation? Quadratic formula, okay? Quadratic formula. If I solve by quadratic formula, I get something like x is negative 1/2 plus or minus, what's the square root of negative 15? Root 15I over 2. That right there is why you use the quadratic formula, not synthetic division. You are never going to find that by synthetic division. Never. Okay? The irrational and imaginary solutions will only be found by getting to a quadratic point and going from there. So your solutions are those three. third degree cubic should have 3 solutions, and we found it. You follow? All right, let's talk graphically then, shall we? Let's start with end behavior. If I have positive x to an even, what should it do on the outside? As x gets positively huge, the result will be positively huge. As x goes to negative infinity, however, because it's an even power, it'll also go to positive infinity. Now, I'm just saying the end behavior because it kind of matters as to what power, x squared, x to the 4th, x to the 6th. It could do a lot of different stuff in the insides based on the power. But the outsides would have to go up and up. What about x to an odd power? Up on the right and down on the left, because negative huge numbers to an odd power would be negative. What about negative x to an even? Both down, and negative x to odd. Up on the left and down on the right, causing our reflection. All right. Now, what about the max number of turns? An x to the n graph could take a max number of n minus 1 turns. For example, ax plus b, also known as a line. How many turns does it take? Let's assume a is greater than 0 for this purpose. It takes 0 turns. Actually, I don't even need the axis. Let's just try to show. It takes no turns. X to the first takes no turns. We'll do the calculus in a second. What about ax squared plus bx plus c? It's a parabola opening up if a is positive, and the second degree takes 1 turn. Yeah? A cube. A cube. Please get now 3 shapes. The one that students remember is that shape. And that's true, that is a cube shape. But it also could look like this. Or this. It could take a max of 2 turns, but it doesn't have to. And x to the 4th. Give me some shapes. Could it take no turns? No, the least it could take is 1 turn, because it's an x to the 4th, it's got to go up and up, right? Could it take up to 2 turns, or 2 possible turns like that? Or it could take even up to 3 turns, right? All right. Now then, let's connect this to calculus, start segueing out. In all these cases, we're going to take the derivative and look at zeros of the derivative. And so from that conclude, let's get to it. All right, now, what's the derivative of y equals ax plus b? Y prime equals a, okay? How many zeros does that have? 0, but it has none. No solutions, none. Now, if it has no zeros of the derivative, then it has no 0 tangent slopes. 0 tangent slopes really mean horizontal tangents. So it has no horizontal tangents. How about a parabola? A parabola, how many places does it have 0 slope? It has exactly 1. Now, why is that? Because the derivative of that equation is, what is the derivative? 2ax plus b equals 0. How many zeros? That is actually, how many zeros? 1, 0. 1 solution. It must have 1 solution. And therefore, it has 1 horizontal tangent. And I'm going to abbreviate that H2. Okay? let's get into the more fun cube. What's y prime of that general equation? Now that's quadratic, right? Quadratic, the derivative is quadratic. It could have ... Now quadratic, can it have two real solutions? Or real zeros? That would imply then that if the derivative has two real solutions, there are two horizontal tangents. Which of those pictures does that indicate? Yeah, the first one has two horizontal tangents. However, a quadratic could have one real solution. For example, if you had something like y prime is x minus 2 squared, how many things make that 0? 1, okay. Now if it has one real solution, there's only one horizontal tangent. Which of those graphs would that case be? That's that one. It has one place it goes horizontal. Or y prime could have 0 real solutions, in which case it has 0 horizontal tangents. And that's that case. You follow? All right. So then, what is y prime of that quartic? 4a x cubed. I got it. Don't you? You just sit there and look pretty. I'll do it. 3bx squared plus 2cx plus d. That's the derivative, Lee. Okay, in terms of cubic, a cube, y prime is a cube. We talked earlier about how an odd degree polynomial must have one real solution. It must. Therefore, if the derivative is a cube, it must have at least one real zero. If you look at these graphs, doesn't every one of them have at least one horizontal tangent? At least one. It's got to. It can't go up and up if it doesn't turn at some point, right? So it must have at least one. It could take up to 3 turns. Could take 3. Okay. That then leads us to the calculus big ideas of the fact. And I mean these gigantic ideas of calculus. If you were to draw a function that's increasing like that, and look at the tangent slopes, what do you notice about the tangent slopes of a function that's increasing? The tangent slopes are always positive. And something that's decreasing, the slopes are always negative. Therefore, if you ever want to show a function is increasing, instead of finding all the y values and say, see, they got bigger, see, they got bigger, then you can just look at the derivative and say, hey, the derivative is positive. That implies the function's got to be increasing. Now let's pause and save me some aggravation, okay? All graphs are read left to right. So I don't want one single person coming to me and saying, yeah, you said that's increasing, but can it be decreasing if I go that way? And the answer is no, it cannot, because you don't go that way. You go this way, period, only. Understood? Don't make up your own math. Okay, so it's left to right, it's increasing, the y values are getting bigger, it is definitely increasing. So proving this, focus please, not just, the math is pretty straightforward. The saying it is pretty picky. In math and on the AP test, if you don't say this well, if you have poor English skills, you will lose some points here. Here we go. This is what I'd like to see here. If I want to find where f is increasing, then I could use this idea. I just need to see where is the derivative positive. That is a well-known theorem that if the derivative is positive, the function is increasing. So I could just say, where's the derivative positive? To find where something is positive, we've done that. It's called a sign test. You first find f prime equal to 0, then sign test around the zeros, and then we'll be able to make our conclusion. So, start with the derivative. What's the derivative? 7x squared plus, what else? 14x minus 21. To see where this is positive or negative, we find a great dividing line between positive and negative. That's known as 0. Okay? How would you solve this? Factor out of 7. Please never divide a greatest common factor over. Why? If that, so a 7's not super important, but if that were a negative 7, and I divided it over, then I sign tested, what would happen? Every one of your results is going to be the exact opposite of what it should have been. Because you divide that negative 7 over, you just changed the signs of everything, and you affected your sign test. Never divide that over. Divide it up front, never over. Okay? X squared plus 2x minus 3. And that factors, how does that factor? Plus 3 minus 1. And so your solutions, actually your zeros, that's we're still not done, are 1 and negative 3. Yeah? All right, now our intention was to see where f prime is positive, not 0. So now we go on and say, all right, I have zeros of f prime at negative 3 and 1. Give me a test region below negative, a test point below negative 3. Negative 5. Okay. 7 times negative 5 plus 3 times negative 5 minus 1 is 7 times positive, which is positive. Now I'm going to actually add a layer to my sign test. Besides signs of f prime, I'm also going to make a conclusion about f. If f prime is positive, then what's f doing? Increasing. Okay? What about in the next region? Give me a test point. 0. Positive, positive, negative is negative. Now, if the derivative is negative, the slopes are negative, meaning the function is decreasing. And after 1, say 50 billion, positive, positive, positive is positive. So the function is increasing. Later on, we'll get to something called curve sketching. If I were to sketch f here, increasing, the derivative is 0 here, meaning the curve goes flat. Then decreasing, and the derivative is 0, meaning the curve goes flat, and then increasing. Isn't that a cube shape? Yeah. Okay. So, now we are ready for our conclusion. F is increasing on what intervals? Negative infinity up to negative 3. Do not include negative 3 because it's really neither increasing nor decreasing at that point. And where else is it increasing? 1 to infinity. When I say, oh, I forgot to say justify. But in the problems, I will definitely remember to say justify. The AP test will say justify. And you'll need to say then why. Why do you say that the function is increasing? Yeah, because the derivative is positive. Because f prime is positive. Okay? You can say it's greater than 0. You don't have to say words. You can definitely use symbols. Okay? Does that make sense? If I asked you, where does f of x have a horizontal tangent? Justify. You would say, f of x has horizontal tangent at x equals -3 and x equals 1 because f prime equals 0. Okay? Remember, the derivative gives you the tangent slope. All right, now then, that leads to one of the greatest uses of calculus, the one that you've used most in business calculus, maximization or finding maximums. If, besides saying something is increasing and then decreasing, if I can see that f prime goes positive to negative, then I just found a maximum of the function. Without a calculator, I can find that maximum. Or if I can find a place where the derivative goes negative, then positive, then I just found a minimum to the function, and I can justify that. Now then, this then is the first derivative test. This is a big idea of calculus. It's normally not until set 40 something, but you guys are doing pretty well, and the quicker I can get this in, the quicker I can start to give you repeats and stuff. So we're going to get this in now, at least for polynomials. Unfortunately, this comes without the steps that I wanted to put in here. I was running behind this morning, I apologize. So the first derivative test, in terms of what I want to see, all right, if I want the relative extrema, that means extreme values, which is just code for min or max. Those of you who, for calc honors, know there's a difference between relative mins and absolute mins. We'll get into that later, but for now we're just going to call them mins and maxes. All right? In order to find these mins and maxes, we first need to find where the graph goes flat. Now, those are good candidates for mins and maxes, but not guaranteed mins and maxes. You can see that that is a place where the graph goes flat and is a max. That's a place where the graph goes flat and is a min. But the graph goes flat here, but that's not a min or a max because the derivative doesn't change signs after from positive to negative. So we're going to look for horizontal tangents and then test around them. So the first thing is you'll take the first derivative. Find the first derivative. What is the first derivative of this function? Negative 4x cubed plus 9x squared. Okay? You're then going to set the first derivative equal to 0. Solve. How would you go about solving that? Factor out an x squared, leaving you with negative 4x plus 9 inside. So your places where x equals 0, or this equals 0, the derivative is 0 at 0 and 9/4. Okay? I just found horizontal tangents. But as I said, we still have to go further to say what's going on around those horizontal tangents. Is the slope going to change or not? So now we're going to sign test around these points. So on a number line, I can place 0 and 9/4. And I am of the habit of saying f prime and then making a conclusion about f around that. If I look at f prime, or the sign of f prime, really, not the values, just the sign, and anything negative, x squared is always positive. That's a square, so that's a positive. In fact, I could say, forget that nonsense. I know that at x squared, it's always going to be positive. What about at negative 15? If I put a negative 15 in or negative 50 in for x, what do I get? Positive or negative? I get a positive. So overall, the results are positive for the derivative, which means the function is increase. Now at 0, the derivative is 0, so that means the graph is going to go flat. We just said those are horizontal changes, right? What about from 0 to 9/4? Give me a test number. 1. 1 squared is positive. We already know that. Negative 4 plus 9 is positive. See, this is one of those cases where if you're going too fast, you say, oh, these scientists are so stupid. They just always change positive, negative, positive. No, they don't. Okay? They do sometimes go back to being positive, as this case. So this went flat, but then it went back to increasing until at 9/4 it flattens out again. And then after 9/4, say at 5 billion, positive, negative 4 times 5 billion plus 9 is negative, meaning the derivative overall is negative, and so the function starts to decrease. Does that shape kind of jive with what negative x to the 4th should be? Yeah, all right. Now the conclusion. Please, I beg you, write this down in your notes and use it as a reference. I can't tell you, it's age-old story. Calculus teacher teaches exactly how he wants it said. Calculus student says, screw that, I'm going to do it my way. And then calculus teacher takes off point after point after point after point until the student finally says, okay, I'll do it your way. So let's just go straight there, shall we? It goes like this. First of all, be careful with subjects. F has a max at, where does it have a max? X equal 9/4. Because, how do I know it has a max? Why does it? All right, because F prime changes sign, or you don't even need to say changes sign. You could just say changes from. I'm just going to keep it clean. Changes from positive to negative. There. Okay, so let me warn you. F has a max because F prime changes sign. Not F prime has a max because F changes sign. Understood? Okay. Furthermore, I never said has a max at. I actually put a subject into the sentence. Okay, it's not just max at because blah blah. F has a max because F prime. Nowhere in here did I ever say a pronoun. You will never use it has a max. Worthless. Never. F has a max as F prime changes from positive to negative. You with me? Last possible place you will go your own way, go rogue on me. I notice I didn't say F has a max at 9/4 because F goes from increasing to decreasing. Is that true? It is true. It's absolutely true. Super true. And yet, nowhere in any calculus textbook will you ever see the F changing from increasing to decreasing test. It doesn't exist. How do you know it's increasing? Because F prime is positive. Why not cite the actual symptom or the cause instead of the symptom? All right, you don't give me increasing to decreasing. It's not the increasing to decreasing test. It's the first derivative test, and you should have the first derivative in it. And if you don't, you will lose. Okay? Try this one on your own and say the conclusion. Well, by the way, I'll mention this. You might find that you have two maximums or two minimums. If you have two maxes, then you can just put it together into one statement. F has a max at blank and blank because F prime goes blah, blah, blah. Okay, you don't have to skip separate statements. Try that on your own. I'm going to head back to the papers. And then we'll be happy. Hi. Sure. How are we doing? All ready? People new to calculus. Okay. Finish this. All right. So, how many critical numbers or interesting numbers? We haven't even heard that vocabulary yet. How many places did you get a horizontal tangent? 3. Does that seem to jive with the shape of an x to the 4th? Okay. So your derivative is x cubed plus 12x squared minus 13x equals, and then set that equal to 0. Read. How'd you do the algebra? Factor out a greatest common factor. And when you took an x out, how did the trinomial factor? X plus 13, x minus 1. So you get 3 horizontal tangents at x equals 0, at x equals negative 13, way off to the left, and at x equals 1. Yeah? Negative 13, 0, and 1. What did your sign chart for f prime look like? Starting at the left. Negative, positive, negative, positive. Because that then, at 0 slopes, then that indicates that it went decreasing, flat, increasing, flat, decreasing, flat, increasing. Does that jive with x to the 4th shape? Seems to verify what we know about polynomial shapes. Okay, you have all these built-in checks for your calculus from pre-calculus material. All right. Now the first derivative test, if well, you can. The picture says all. Don't you agree that we're getting 2 minimums here? So let's talk about the conclusion. F has minimums at x equals negative 13 and 1 because f prime changes from negative to positive. Okay? And you have one max. F has a max at x equals 0 because f prime changes from positive to negative. Okay, cool. That's about what the first derivative test should look like. You just read the first derivative test. Yes?
Can we combine the two conclusion statements and then just say that this f prime changes sign?
Absolutely not. Here's why. It doesn't, saying changes sign doesn't tell you if it's a min or a max. It's how it changes sign that's important. Okay. you have to be specific about how it changes sign. Min only happens if the sign changes negative to positive. Max only happens if the sign goes positive. So they're very different. That's a great question. I'm glad you asked it. You cannot. Minimums behave the same, so you can combine those into one, but max and min are different. So glad you asked that. All right. And whether you know it or not, you can actually do that kind of statement, what you're talking about, for inflection points, but that's a later day. That is that. I posted Fund 2's keys, so I don't know if you have questions on Fund 2. People who were absent, there was a test review given out on Thursday, so I would look at that sheet in the key to make sure you are ready for the test. And questions on Fund 2? Anybody? If you're absent, by the way, there are some in the back folder, AB folder. You can put it there. All right, I'll let you work then. Make sure I get Fund Sheet 2 today. If you didn't already, turn it in the other day. And I have lots of papers from here and back, so I'll get you those in just a minute. And we'll all be happy. Yes.
Good morning, Dublin Jaguar. Please rise for the Pledge of Allegiance. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Seventh graders will be required to report to the auditorium for a counselor presentation on anti-bullying. Today, seventh graders will class in stage entry will be required.
Come support the marching band at the Jesco Marching Band Festival on Tuesday at the Jesco Stadium. The band performs at 5:45 with a 2013 show
Even tutor, sign up using the peer tutoring request form found on the Dublin homepage under academic peer tutors. You may also send this to the contact or your counselor for more information.
Are you good at multitasking? If so, prepare for tie-dye and support student council and the Make-A-Wish Foundation all at the same time. It's simple. For only $10, you can purchase a one-of-a-kind DHS wishing shirt. It will support Luke, our Make-A-Wish kid who is diagnosed with leukemia.
Today, the University of Pennsylvania from Philadelphia and Colorado University will begin counseling. You will be here at 1:30 p.m., so make sure you have a pass if you want to attend.
Tomorrow, Metro State University of Denver will be visiting with prospective students. Find all audience and counseling for 7 hours.
Marcher planner, the Denver National College Fair is coming up on Sunday, September 24th, 2017, from 1 to 4 p.m. at the Denver Farm. Over 300 colleges and universities will be visiting with students. Must re-register. See those that are cool or not by county.
The NACAC College Fair is this weekend. Colleges from around the world and the United States will be visiting us the next 2 weeks. Most of these visits are during class time. It is the only time you are allowed to mix crafts with the approval of your teacher. You will need a pass to sign up using Navia.
Teachers, are you looking for a 4-year renewable scholarship? This Daniels Fund Scholarship is looking for students with strong character, leadership potential, and who demonstrate financial needs. The online application is open from September 29th to November 30th. Counseling has the information.
Students, would your parents like to get to know your counselor? You are in luck. Remind your parents there is coffee with the counselor this Wednesday morning, September 20th, from 7:30 to 8:30 a.m.
Natalie Jags, our 4-3 soccer team defeated Ponderosa 3-2 in double overtime last Friday evening. Anna Sharp, Dave Arbanoff, and Kyle Boyd scored for the Jags with a single right category. St. Hatfield had 11 saves and goals. Next game is Tuesday, September 19th against Evergreen at 5 p.m. Lakewood Memorial Field.
Also this Friday, start thinking about if your volleyball team's first home game of the season. It's at 6:30 here at Dublin. Wear a tie-dye. That's all I announcements. Have a great day.
Negative 0, or 960, or 970. For what? I don't finish problems fast. It's not big. Is this it?
Okay. Let's